Hello everyone. Today we talk about more about the API gateway. Inside we go in deep and dive. Okay, so let's start. Okay, so first question comes in like API gateway solve multiple problem in microservice architecture. API gateway solves multiple problem in microservice architecture. Okay, so let's take first. So it basically remove client complexity. Without a gateway, the client must call multiple services directly and manage different URLs. So let's take the without a gateway, the client must call multiple services. Client must call multiple services directly and manage different URLs. Okay. So second, it's centralized cross-cutting concerns. Second, it centralizing cross-cutting concern. Like authentication, logging, rate limiting, and monitoring. Okay, so third, it has improved security. Okay, instead of exposing all microservices to the public, all microservice to public, only the gateway is exposed. It is scoped. Okay, let's take fourth. It enables response aggregation. Okay, let's take fourth. It enable response aggregation. Okay, the gateway can combine response from multiple services into single response. The gateway can combine responses from multiple services into single response. Okay, let's take finally it decouple client from internal service structure. It's decouple clients responses from multiple service into it's decouple. Okay, let's take another fifth. Finally, it enable it decouple clients from service internal service structure. If internal service change, client are not affected. That is architectural advantage. That's the architectural advantage. Okay. Okay. So let's talk about the second questions. Can API gateway become a bottleneck? A bottleneck? Okay. So let's talk about the since all traffic flows through the API gateway. Since all traffic the API gateway, if it is not properly designed, if it is not properly designed, it can become a performance bottleneck. Performance bottleneck and single point of failure and latency contributor. Okay. Okay, so let's talk about the solution. If the gateway perform heavy processing like complex transformation or synchronous calls, response time increase. Okay, so let's talk about the to avoid this. Keep gateway lightweight. Avoid heavy business logic. Use asynchronous communication where possible. Deploy multiple instances. Enable horizontal scaling. Okay, the gateway should do one only handle routing and policies, no business logic. Only handle and policies, no business logic. Okay. Okay, so let's talk about the third questions. How do you handle high availability? Okay, so let's consider that part. To ensure high availability, first deploy multiple API gateway instances. Okay, and second, place them behind the load balancer. And the load balancer distribute traffic across multiple gateway instances. Okay, if one instance fail, other continues serving the traffic. Okay, so we can use like Nginx, Kong, Amazon API Gateway, Azure API Management. Okay, in cloud environment, auto scaling group help scale based on CPU and traffic load. Okay, so in cloud environment, auto scaling groups help scale based on CPU or traffic load to remove single point of failure. Okay. Okay, so let's talk about the difference between API gateway and reverse proxy. So let's take question 4. Difference between API gateway and reverse proxy. And reverse proxy. Okay. So let's talk about the answer about a reverse proxy mainly forward client respond to backend server. Mainly forward client request to backend service. Okay, it handle routing, SSL treatment, basic load balancing. Okay, and API gateway does much more. Okay, it handle authentication and authorization. Rate limiting, API versioning, request transformation, response aggregation, monitoring, and caching. Okay, in simple terms, reverse proxy traffic forward is equal to traffic forward. And API gateway traffic controller plus policy manager plus policy manager. Okay, tools like Nginx can act both. Can act both. Act as a both, but API Gateway has more advanced API management feature. Has more advanced features. Okay, so let's talk why should you avoid API Gateway. Next question is 5. When should you avoid API Gateway? Okay, so let's take answer. So you should avoid when your application simple monolithic application. You have a simple there are very few steps. System component complexity is low. Traffic volume is minimum. Okay. Introducing API gateway smaller system. Introducing a smaller API gateway in a smaller system. Add unnecessary complexity. Okay. So also if microservices are internal and not exposed to public, and also if microservice is internal and not publicly. Okay, you might not need to a full API gateway. Okay, always evaluate architecture's maturity before introducing it. Before introduce it. Okay, so let's take important design consideration. Important design okay, if not designed properly, it become a single point of failure. It can increase latency. It it can become a performance bottleneck. Okay, so best practice: deploy multiple instances, use load balancer, keep it stateless, keep it stateless, and monitor metrics. And class important circular circuit breaker pattern. Okay, so gateway should be thin, not fat. Thin, not fat. Okay, so let's take some strong points. An API gateway is a powerful, but it should lightweight and horizontal scale. If overloaded with business logic, it differ it defects its purpose and become a bottleneck instead of solution. Okay, that's about it. Okay, so let's say take revise it if once more. Okay, so let's talk some more problems inside. Like an API gateway solve multiple problem in microservice architecture. First, it removes client complexity. Without a gateway, a client must call multiple services directly and manage different URLs. Second, it centralizes cross-cutting concerns like authentication, authorization, login, rate limiting, monitoring, etc. Okay, so let's take third, improve security. Instead of exposing all microservices to public, only the gateway is exposed. Let's take fourth, is enable response aggregation. The gateway can combine responses from multiple services in single responses. That means the multiple API service need to authenticate, authorize, security, rate limiting, and this type of stuff. They all response aggregated. Aggregation used inside it. Finally, it decouple client from internal services structure. Okay, if internal service change, client not affected. We just read out reversioning and we can do that part. If anything failure or anything maintenance will happen, we just change it inside the API gateway to previous one and it's working fine. That is an architectural advantage. Okay, so can API gateway become a bottleneck? Okay, since all traffic flow through the API gateway, it not properly designed, it can become performance bottleneck, single point of failure, latency contributor. Okay, so if the gateway perform heavy processing and the complex transformations or synchronized calls, response time increase. To avoid this, keep gateway lightweight, avoid heavy business logic, use async communication where possible, deploy multiple instances, and enable horizontal scaling. The gateway should only handle routing and policies, not business logic. Okay. How you handle high availability? So let's check out. To ensure high availability, first deploy multiple API gateway instances. Second, place them behind a load balancer. The load balancer distribute traffic across multiple gateway instances. If one of instances fail, other continuous serving traffic. You can use Nginx, Kong, Amazon API Gateway, Azure API Management. In cloud environment, auto-scaling groups help scale based on the CPU and traffic load to remove single point of failure. Okay, different between API gateway and reverse proxy. Okay. So the reverse proxy mainly forward client request to backend services. It handles routing, SSL termination, basic load balancing. An API gateway does much more. It handles authentication and authorization, rate limiting, API versioning, request transformation, response aggregation, monitoring, and caching. In simple terms, reverse proxy traffic forward, API gateway traffic controller plus policy manager. Tools like Nginx can act both, but API gateway has more advanced API management features. Let's take fifth. When should you avoid API gateway? You should avoid an API gateway when you have a single monolithic application. There are very few steps. System complexity is low and traffic volume is minimum. Introducing API gateway in a small system adds unnecessary complexity. Also, if microservice internal and not exposed to publicly, it might no need to use full API gateway. Always evaluate architectural maturity before introducing it. Let's take important design consideration. This is very important section. If if not designed properly, it become a single point of failure. It can increase latency. It can become performance bottleneck. Best practices. Deploy multiple instances. Use load balancer. Keeps a stateless. Monitor metrics. Important circuit breaker point pattern. Gateway should can be thin, not fat. Okay, so let's take strong color closing lines. An API gateway is a powerful, but it should be lightweight and horizontal scale. If overload with business logic, it default, defect its purpose and become a bottleneck instead of solution. If overloaded with the business logic, it default the purpose of the it defaults. The purpose of this bottleneck become a bottleneck instead of solution. That is about it. Okay.